Now, in this video, we're going to answer the following question. Find the area between a curve with equation f of x equals 3x squared minus 2x plus 2, the x-axis, and lines x equals 0 and x equals 2. So the first thing we're going to do is sketch this graph. So I'm going to draw a pair of axes. And now I'm going to substitute x equals 0 into my function. And this will tell me where the curve cuts the y-axis. Now 3 multiplied by 0 squared is 0. And minus 2 multiplied by 0 is also 0. So the plus 2 on the end is the position on the y-axis where this curve intercepts it. Now to find whether this curve intercepts the x-axis, I'm going to use b squared minus 4ac. Now if b squared minus 4ac is equal to 0, less than 0, or greater than 0, we can identify some important information about the roots of this function. So let's go ahead and do that first. Now, because the function is 3x squared minus 2x plus 2, a, which is the coefficient of the x squared term, has the value 3. B, which is the coefficient of the x term, is minus 2. And C, which is the number on the end, is 2. Then B squared would be minus 2 squared minus 4 multiplied by A, which is 3, and C, which is 2. So tidying that up, minus 2 squared is 4, and 4 times 3 is 12, multiplied by 2 is 24. I get 4 minus 24. Now, the fact that it's minus 20 isn't important. What is important is that it's less than 0. And that tells me that this function has no real roots. In other words, it doesn't intercept the x-axis. It does, however, have a turning point. So I'm going to differentiate it to find the position of that turning point. So f dash x is equal to 6x minus 2. And when I make that equal to 0, that means 2 is equal to 6x, and 2 over 6, which is equal to a third, is x. So at the position of a third on the x-axis, we have a turning point. Now, if I wanted to, I could find out the corresponding value of y and put the point, in other words, in exactly the right position. But this is just a sketch, and all I want to know is whether there is a turning point and where on the x-axis it is. So now I'm going to sketch my curve. Now, we're finding the area under the curve between x equals 0 and x equals 2, which is this shaded area here. So in the next step, we're going to integrate this function to find that area. So now we're going to integrate the function between 2 and 0. So 3x squared minus 2x plus 2 with respect to x. So if we integrate this, 3x squared is x cubed minus 2x, which is minus x squared, plus 2, which is 2x. And because this is a definite integral, we don't need a constant, but we are going to be substituting in values of 2 and 0. So beginning with the 2, 2 cubed minus 2 squared plus 2 multiplied by 2 minus, now substituting x into each of these terms will be 0 each time. So the total will also be 0. So we can just put a 0 there. So 2 cubed is 8 minus 2 squared, which is 4, plus 2 multiplied by 2, which is 4. So minus 4 plus 4 is 0. So the answer is 8. So the question, which asked us to find the area between the x-axis and lines x equals 0 and x equals 2, that area is 8. If you found this video useful, please leave a like, comment and subscribe. Thank you.